Remember that there are 4 properties needed to be a cumulative distribution function. Your function needs to be non-decreasing. It's a probability, so it needs to be between 0 and 1. On the right, its limit has to be 1, and on the left, its limit has to be 0. So the function shown here is a cumulative distribution function. Using this cumulative distribution function, just as a quick review, because these are still pretty new concepts, you should quickly be able to give me numbers for these 3 probabilities. Pause the video, come back when you're done. The probability that x is less than or equal to -1, that's f of -1. This is a cumulative distribution function. This is what it does. And f of -1, I can see from the definition, is 1 over e. The probability that x is less than 0, well, that's f of 0. And again, I can see from the definition that this is 1. I want to make a note that my cumulative distribution function is continuous. That means the probability that my variable is 0 is 0. So that means the probability of being strictly less than 0 is the same as the probability of being less than or equal to 0. So in this probability that I just figured out, it didn't matter that the top one was less than or equal to and the bottom one was strictly less than. Because this is a continuous random variable, those probabilities are the same. For the final answer, we need to think a little bit harder. So here's -10, here's -100. If I say f of -10, that's the probability that my value is less than or equal to -10. If I say f of -100, that's the probability that my value is less than or equal to -100. I want everything between them. So f of -10 gives me all of these values. But then I want to get rid of the values I don't want. I don't want to include these values. I don't want to include what happens when f is less than or equal to -100, so I just subtract f of -100. So once again, we define the cumulative distribution function in a very particular way, the probability that x is less than or equal to some number. We've seen that even though the definition is quite particular, we can still use it to describe general things. It doesn't matter in a continuous random variable whether this inequality is strict or not, and we can describe the probabilities of being in ranges just by this easy subtraction. So to generalize that example, if I know the cumulative distribution function of a random variable, and I want to know the probability of being in a particular range, I just take the probability of being less than the top minus the probability of being less than the bottom. And the reason that works is f of b captures all of the pink events, f of a captures all of the blue events, so when I subtract, I get these events between a and b.